Alright, I'm going to go over post test study guide, page 3. I did this in the Google Meet,
actually
but
page
like I said, I think
4.
it looks a little bit nicer when I do it like this. So what you're going to use for this one a bunch is this type of idea. So um, if you haven't filled these out yet, if you don't know that, you're going to want to know that. It's going to be very helpful. Remember, simplifying radicals, it's not just perfect square factors. It's any perfect factor based on the index. So these could all work with square roots, but it also works with any root. You could put a little n there, little n there, as long as the indexes are the same. You can do that. And then there are exponent properties. So that's what we're going to be doing today. All right, so 18. Remember, we're going to be using this property a lot. We're going to talk about a. I don't. We're going to be using this property a lot. Where we talk about a to the m over n can be written as that or that. So if it's a fraction, fraction exponents are kind of hard to do in my head. A little bit easier to do radicals. If it's all numbers, I usually use this one because that's a little bit easier to do in my head without a calculator. So I got to find a, m, and n. So 16 is a, 3 is m, and 2 is n. So I'm put the square root of 16 all to the third power. A lot of times, nobody will write that little 2 there if in like the math world. But if you put that in there, it's totally fine. Some people don't. It's kind of like putting the 1 in front of an x when it's just x. Some people like having that one there because it reminds them, but most math guys don't write it. So the square root of 16 is 4, so it becomes 4 cubed, which is 64. That is C. For 19 and 20, you're just rewriting. So 19, it kind of looks like this. So it means I want my answer to look like this or this. It doesn't matter which one you use. I'm going to put, so that is A, that's M, that's n. So I'm going to put the fifth root of 8, anything to the first power is just itself, so I just put the fifth root of 8 as my answer. A is 24, m is 2, n. So we look like this side, so my answer is going to look like that. So I'm going to put 24 to the 2/3, and I'm done. I didn't tell you to simplify it, so you don't have to. All right. 21. We're going to be using those exponent properties on your hint page from the first slide. So a to the m over a to the n. That's what I'm going to start with. Remember, you're going to subtract the exponents. So since those bases match, I'm going to put 16. I'm going to do 1/6 minus 2/3. Now I'm going to make 2/3 into 4/6, so then I can subtract those. So 2/3 is the same as 4. So I'm going to end up with 16 to the negative 3/6, which is 16 to the negative 1/2. Now remember, you cannot have a negative exponent, so we do have this property that says if you have a negative exponent, you move it down to mom's basement to make it positive. So this is going to turn into 1 over 16 to the 1/2. Now if you didn't know that, the 1/2 is the same thing as the square root of 16. So I'm put the square root of 16, which is 1/4. So this whole thing right here turns into 1/4. Right? 22, I have the cube. I'm going to take the radical of the top and the bottom. So the cube root of 1 over the cube root of 3. So it's going to become 1 over the cube root of 3. Now remember, I cannot have a radical in the bottom. That's like one of the rules. So that's where my box comes to play. If you guys remember that box we said where it has to equal 1, I can choose whatever I want inside this box as long as the top and bottom match. This is 3 to the first. If it was 3 cubed, the radical and the exponent would cancel. So I really want to have 2 more 3's, because then it would give me 3 cubed. So I pick to have the cube root of 3 squared on the bottom, and I'm allowed to do that as long as I put that on top. So now I'm going to multiply across the top. So the top turns into the cube root of 3 squared, which is 9. All over the bottom turns into the cube root of 3 cubed. The little 3's cancel. I end up with the cube root of 9 all over 3. That's my answer. All right. All right. So number 23. Remember, 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 48 is not on that list, but 48 is 8 times 6. Now I know that I only care about 8 times 6. I know 48 is also 24 times 2. I know 48 is also 16 times 3. I only care about 8 because 8 is on the list. So this 8 gets to leave. He turns into 2 because the cube root of 8 is 2. 6 stays in jail forever, which is C. Now, for 24, you could rewrite this as x cubed, x cubed, x cubed. So those are 9 x's. I just wrote as x cubes. I could take those y's. There's 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Now it seems kind of silly to write all those y's out. So there is a shorter way to do it. So, but really what this is going to say is 1, 2, 3 x's get to leave. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So when I write that, I can write that as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Really kind of silly to write it, take all this time to do this problem, and really the easiest way to do it is just do 9 divided by 3. 9 divided by 3 is 3 with nothing left over. That's how I know 3x is coming to jail. 36 divided by 3 is 12. That's how I know 12y is coming to jail. Which, that's what this turns into anyhow. 25. These are exactly the same. So that means I get to add those numbers up front. Negative 1/2 plus 3/2 is 2 over 2. So the best answer is just the cube root of 20, or just 1 cube root of 20. 26. These are not perfect. 64 goes into this 2 times. 216 goes into it 2 times. So 216 is 6 cubed. 64 is 4 cubed. So this becomes, so this 64 turns into 4 outside the radical. This 216 turns into 6 outside the radical. So I have 4 times 4 cube roots of 2, so that 2 stayed in jail, minus 2 times 6 cube roots of 2. So now I have 4 times 4, which is 16 cube roots of 2, minus 12 cube roots of 2. That's going to give me 4 cube roots of 2. Best answer. All right, 27, 28, and 29 are kind of a new idea. We haven't really actually got a chance to talk about those yet. We're actually going to come up on those really quick. And then kind of we just didn't get to it. So, compositions. So compositions are like functions inside of functions, or problems inside of problems. It's kind of like those nesting dolls. If you guys like think about that way, where you have a doll inside of a doll, that's kind of what it is. So if you want to think nesting dolls, that's fine. I don't know if you guys know what those are, but all right. So I'm going to put f of x inside of g. That's how. So this actually says g of f of x. All right. So I got to figure out what I always do is the reason I always start with what I read first. So look, when I look at this problem, when it tells you to find g of x, g of f of x, look, I start g in the front, so I'm only going to worry about g right now. I'm not even worried about f of x. So I'm going to just start, I'm going to write g of x equals 6x squared. All right. Now the reason it's called g of x is because we're using x as a variable. If I take that x away, I have to take that away. So if I said g of stick figure, it would be 6 times stick figure squared. Right? If I said g of y, it would be 6 times y squared. All right? That's kind of how it works. So basically, when I take this, I am rewriting, but instead of a variable, I'm putting f of x. So I'm putting f of x. Now, I don't know what f of x squared is unless, remember, I could rewrite f of x as x squared. So g of f of x is equal to 6 something squared. But instead of f of x, I'm going to put x squared plus 5. So now I put the first problem inside the second problem. Now I just have to do some math. Now you have to remember you are not allowed. This is not okay. Do not do that. Everybody tries to do that. Remember, you have, because of that plus 5, that plus sign, you cannot do that. So what we're going to do is, the only way I really know how to do this is I'm going to take this, I'm going to write it as 6 x squared plus 5 next to x squared plus 5, and now I'm going to FOIL. So x squared is x squared, gives me x to the 4th. X squared goes to 5, gives me plus 5x squared. X squared goes to 5, gives me 5x squared. 5 goes to 5, gives me 25. So this becomes 6 x squared plus 10x plus 25. Now 6 goes to everything. So my final answer is g of f of x equals 6x squared plus 60x plus 150. All right, and that's it for 28 or 27. So it is a new idea. Now with 28 and 29, it's slightly different when there's numbers. When there's numbers, I do it a little bit different. Now you could do it the same way. So what I'm going to do is I'm going to start with, just like we said, I'm going to look at what's first, g. So I'm going to put g of big blank space. So there's g of x. So g of big blank space is going to be 2 over, instead of x, I put a big blank space. All right. So I did have an x there, but what I did is I took the x out. So inside here has to be g of negative 1. So basically I'm doing a problem inside of a problem. So what I'm going to do first, now I'm going to do g of negative 1. So g of negative 1. G of negative 1 is 2 over negative 1. So g of negative 1 equals negative 2. So what I'm going to do is I'm going to put g of negative 1 on this side. I'm going to put negative 2 on that side. So g of negative 1 is going to be 2 over negative 2, which is negative 1. That's it. We're done. So that's just, I think, the easiest way to think of it. So like 29, for example, 29, the first thing I see is f, so I'm going to start with f. I'm going to put f of big blank space. So I'm going to put 1 plus, instead of x, I'm going to put a big blank space. So normally I would put x there, right? But I'm not going to do that. I'm going to take the x out. Now, inside here is g of 2. So like this is, I'm going to kind of do this as like scratch work. G of 2 I want to put in here. So I got to find out what g of 2 is. Well, g of 2 is 2 over, instead of x I put 2, which is 1. So I put that 1 right there. So f of g of 2 is going to be equal to 1 plus 1 squared. So f of g of 2 is going to be equal to 2. And that's it. I don't remember if I did it keyword or not. So we'll say the keyword is loud boys. My boys are being kind of loud in the background, so, and the babies, but just loud. The keyword is loud. Keyword is loud.